Every model so far had a teacher, labeled examples telling it the right answer. Now we cut the teacher loose. Given only raw data with no labels at all, can a machine find structure on its own? This is unsupervised learning, and its most famous algorithm is beautifully simple: K-means clustering. Here's the setup. You have a pile of data points, but nobody has told you what any of them are. No cat or dog, no categories. The only thing you have is the points themselves and their positions. The goal? Discover natural groupings, clusters of points that belong together, using nothing but their similarity. Look closely and structure often jumps out. Points clump into blobs with gaps between them. Clustering is the task of finding those blobs automatically, putting similar points in the same group and dissimilar points in different ones. It's how you discover customer segments, group documents by topic, or spot natural types in data nobody has organized. K-means starts with a decision. How many clusters K do you expect? Say 3. It drops 3 points called centroids, the proposed centers of the clusters, randomly into the data. They're just guesses for now, almost certainly in the wrong spots. The algorithm's whole job is to walk them to the right places. Step 1 of the loop: assign every point to its nearest centroid. Each point simply joins whichever center is closest. Color them accordingly, and the space snaps into regions. Every point now belongs to a tentative cluster. It's the same nearest idea from k-nearest neighbors used to draw the groups. Step 2. Move each centroid to the average position of all the points assigned to it, the mean of its cluster. The center relocates to the heart of its group. Now that the centers have shifted, some points are suddenly closer to a different center than before, which means we need to reassign. And that's the entire algorithm, just 2 steps repeated. Assign points to the nearest centroid, move each centroid to its cluster's mean, assign again, move again. With every pass, the centroids drift toward the dense centers of the blobs until they stop moving. When nothing changes, it's converged. The clusters are found. But how many clusters should there be? Too few, and you merge distinct groups. Too many, and you split natural ones. A common guide is the elbow method. Plot how tight the clusters are as you increase k, and look for the bend, the point where adding another cluster stops helping much. That elbow is often a sensible k. K-means is everywhere because it's simple and fast. It scales to large data sets, it's easy to understand, and it usually converges in just a handful of passes. As a first look at unfamiliar data, what natural groups live in here? It's often the very first tool people reach for, but it makes strong assumptions. K-means expects clusters that are roughly round and similar in size, so it stumbles on long, stringy, or nested shapes. You have to choose K in advance, and a bad random start can land it in a poor solution. A smarter initialization, K-means plus plus, spreads the starting centroids out to avoid exactly that. When K-means doesn't fit, others do. Hierarchical clustering builds a whole tree of nested groups, so you don't fix K up front. DebScan finds clusters by density, handling weird shapes and flagging outliers as noise. Different tools for different shapes, but they all chase the same goal: structure found without labels. The applications are huge: segmenting customers into marketing groups, compressing an image by reducing it to K representative colors, organizing documents, grouping genes, spotting anomalies. Anytime you have data and want to ask what types are hiding in here, clustering is the answer. No labels required. So that's K-means. Guess some centers, assign points to the nearest, move the centers to the mean, and repeat until they settle. A tiny loop that uncovers hidden structure from raw, unlabeled data. Next time we close out the classical block with a classifier built on nothing but probability. Fast, surprisingly effective, and a little bit naive. See you there.